These are the continents on planet Earth. If you look carefully, almost all of the continents appear to fit perfectly into each other. This means for the past millions of years, several supercontinents have formed and broken apart. This phenomenon is backed by the theory of continental drift and plate tectonics. For the past billions of years, planet Earth has undergone numerous massive transitions to be able to accommodate life. Estimates suggest that the Earth weighs about 6 septillion kilograms. Every single piece of landmass took millions of years to form. Primarily, the Earth is made up of 3 main layers: the crust, the mantle, and the core. The crust, which is the outermost part of planet Earth, or where humans live, is the thinnest compared to other layers. The mantle is also divided into 2 layers, the upper mantle and the lower mantle. Together, the crust and the upper mantle are known as the lithosphere. Now, the Earth's lithosphere is cracked or broken into about 15 major and minor pieces called tectonic plates. There are several major plates such as the Pacific Plate, North American Plate, Eurasian Plate, and many more, as well as numerous smaller plates. These plates fit together like a puzzle. Every landmass and ocean lies on these plates. In the early 20th century, a German meteorologist named Alfred Wegener suggested that the continents were once connected as a single landmass or supercontinent called Pangea and have since drifted apart over geological time. Wegener observed that the coastal lines of several continents, such as South America and Africa, appeared to fit together like pieces of a jigsaw puzzle. He also noticed similar rock formations, identical fossils, and comparable mountain ranges in the coastal areas of these continents, leading him to propose that these landmasses were once part of a larger interconnected supercontinent. Despite presenting such a compelling evidence, Wegener's theory faced a significant opposition from the scientific community during his lifetime. His biggest challenge was explaining the exact mechanism behind continental drift, which Wegener was unable to provide. It wasn't until the mid-20th century, with the development of the theory of plate tectonics, that Wegener's ideas gained widespread acceptance. Now, according to further studies, the Earth's lithosphere, which consists of the rigid outer layer of the planet, called tectonic plates, is constantly moving at a distance of 1 to 2 inches per year. Plate movement is caused by the heat-driven flow of mantle material beneath the tectonic plates. Plate boundaries are the areas where these plates interact with each other. There are 3 main types of plate boundaries. Divergent boundaries. This is where plates move away from each other. Convergent boundaries is where plates move towards each other. The Himalayas were formed as a result of the collision between the Indian and the Eurasian plates. And the last, transform boundaries, is where plates slide past each other horizontally. The San Andreas Fault in California is an example of a transform plate boundary. The interactions at plate boundaries lead to various geological phenomena, including earthquakes, volcanic eruptions, and the formation of mountain ranges. At convergent boundaries, one plate may be forced beneath another in a process called subduction, leading to the formation of volcanic arcs and deep ocean trenches like the Mariana Trench, which is the deepest point of the ocean. It is about 36,070 feet beneath sea level. For reference of how deep it is, you will need to arrange 34 Eiffel Towers on top of one another, starting from the bottom of the trench to get to the surface or the sea level. Continental drift and plate tectonics can also lead to changes in ecosystems and the loss of biodiversity. As land masses shift and collide, habitats are altered or destroyed, disrupting the delicate balance of ecosystems. Species that are unable to adapt quickly enough may face extinction, leading to a decline in overall biodiversity. About 335 million years ago, during the late Paleozoic era, one of the most famous supercontinents in Earth's history, Pangea, began forming. Pangea's assembly was a consequence of the collision between several major landmasses, including North America, South America, Africa, Europe, and Asia. The closure of the ancient Tethys Sea marked a pivotal moment in Pangea's formation. Pangea's existence had profound implications for the planet. The supercontinent created vast interior deserts and altered ocean circulation patterns. The formation of Pangea also played a role in the mass extinction event that marked the end of the Permian period, the end Permian mass extinction event. According to scientific research, it is the deadliest and the most notorious natural disaster to have ever occurred on planet Earth. It happened about 252 million years ago, during the Permian period. Due to its fatal nature, it was given the name the Great Dying. Over 90% of all marine and terrestrial species went extinct. This paved the way for the rise of the dinosaurs in the subsequent Mesozoic era. Pangea's reign eventually came to an end as the forces of plate tectonics initiated its breakup. According to geological and paleomagnetic data, Pangea is not the only supercontinent that has existed on planet Earth. The story of supercontinents begins in the distant past, during the Archean Eon, approximately 3.6 to 2.8 billion years ago, with the formation of Valbara, the earliest recognized supercontinent. Following the breakup of Valbara, another supercontinent, Kenoland, emerged around 2.7 to 2.1 billion years ago. The assembly of the continents continued, leading to the formation of the supercontinent Columbia around 1.8 to 1.5 billion years ago. Rodinia then followed. In the late Precambrian era, around 600 to 540 million years ago, Pangaea formed. Its breakup contributed to the Cambrian explosion of life. This made it possible for some Cambrian sea creatures, like Anomalocaris, to dominate the Cambrian oceans. And finally, Pangea formed during the late Paleozoic era, approximately 335 million years ago. The dynamic nature of our planet ensures that the story of supercontinents is far from over. Scientists predict that a future supercontinent may form millions of years from now, reshaping the face of Earth once again. This is the Busy IQ.